So we are going to unit 2 now, and it's polynomial equations and inequalities. So we are going to cover some topics here. We'll go one by one, and these all pages that I show here, they are available in the portal. So you can have a look on that. So the first topic we have is the remainder theorem. So what it says that when we divide any polynomial by another polynomial, then how we can express that polynomial in the form of remainder theorem. So like you can see here, there is some example. So we are trying to divide 9 by 2. You know that it will give you 4 as quotient, 1 will be remainder, and you are dividing by 2. Okay, or you can just write it maybe 4.5. Okay, similarly, you can also write in this form. We call it dividend, and this is called divisor, and that's called quotient, and this is called remainder. So there are two forms by which you can write the same polynomial function. So you can write it like, say, if px is a polynomial function and dx is the divisor function and qx is the quotient, rx is the remainder, then this is the way you can write it. Or there is another form that you can use. You can just write it px equal to qx times dx and plus rx. So same thing. Okay, and then we have to look into the factors also. If you divide a polynomial by another polynomial and that polynomial is binomial, like we have only two terms, and if that's a factor, then we should know that the remainder should be 0. So we have here, we have to do long division and we have to do synthetic division. So I will show you both how to do them. So for the long division, we have to do the way we divide numbers. Like, say, I'm going to say 57 divided by, say, let it be 7. So we say 7 times 8 is 56, and then we have remainder as 1. Okay, so this is the way. So how we can do the same thing here for this function? So we write it 2x cubed minus 3x squared plus 8x minus 12, and we try to divide it by x minus 1. Okay, so what is our strategy here? We have to look into this first factor and we have to look into this factor and make sure we have to find any expression which multiplied by x generate this value. So obviously it's 2x squared, so you do 2x cubed and then multiply this also here, so minus 2x squared, and then you just subtract this from the polynomial, so this will cancel, and here you will get minus x squared, and then you can bring the next term down, so 8x, and then we'll try to have the same strategy. We're going to make the same first term, so I will do that minus x squared plus x. Again we subtract them, so sign will change here, so this will cancel. You get 7x and minus 12, and then you want to have 7x here, so you will do plus 7, so you get 7x minus 7, and when you subtract it, this will cancel, you will get here negative 5. So in this case we have qx as 2x squared minus x plus 7, and rx in this case, though this is a constant, so it's just negative 5. And if I have to write this expression now in terms of remainder theorem, then it should be we'll say 2x cubed minus 3x squared plus 8x minus 12, okay, divided by x minus 1. It should be equal to 2x squared minus x plus 7, which is basically our quotient, and then we show plus, then we write remainder, which is negative 5, and over divisor the x minus 1. Or you can say this plus and minus, it just makes minus. The only thing you need to make sure, students, here you write these terms in the decreasing order of their degrees. So if some degrees are missing, please make sure you have them with the 0 leading coefficient. Okay, so let me write it on a separate sheet. So say you have some function here fx equal to say 2x raised to power 4 plus 3x plus say 7, and you are trying to divide it by x minus 1. So what you do, you write 2x4 plus 0x cubed plus 0x square plus 3x plus 7, and then you divide it by x minus 1. So make sure you don't miss this part, otherwise you will end up doing it wrong, or it may be a little complicated for you to solve it. So now look into this. You see the remainder here is non-zero. That means x minus 1 is not a factor of this. So it's not a factor of the polynomial. Now the other thing we do, synthetic division. So again students, synthetic is very simple to do. So what we do, first we write the leading coefficient of all these terms. Again, if some leading coefficients are missing, please make sure you write it 0. So I will write here 2, then I write negative 3, then I write here 8, and then I write negative 12. And then we draw a line like this. And here we write the divisor. So we get the value of x from here. So it's x equal to 1. That's how we find it. And we write that 1 here. Now what you will do, bring this 2 number down. So write 2 here. And then multiply it by 1. So 2 times 1 is 2. And just add them. So negative 3 plus 2 is negative 1. Again do the same process, negative 1 times 1. So you multiply again then. So that will be your next term. So negative 1. And then you do this addition here. 8 negative 1 is plus 7. And then again you do the same thing. 7 times 1 is 7. And you say here negative 5. Now whatever you are getting at the end, that's your remainder. And these terms that you have, you just have to reduce the degree by 1 from the original. So we have here degree 3. So we have to write degree 2 here. So it will come now 2x square minus 1x, that means just x, and then plus 7. And your remainder is 5. And you can see both these expressions, they are giving you same values. Okay, so long division is you know, it's you have to go through multiple steps, but synthetic division you can do in a single step. But single step, the synthetic division we prefer when we have integer, you know, the value of a as integer. So for example, say if we say divide some function, like say we have a function here fx equal to 3 x raised to power 5 plus 4x square plus 37 something, and we say divided by, let it be say 3x plus 4. So in that case, because if I isolate x here now, so x will be equal to negative 4 over 3. So that will be slightly tricky to solve with the help of synthetic division. So in that case, you preferably want to have the long division. Otherwise, it's your choice, unless or until it is given to you, but method you have to use. You can use any method that you want. So these are how we can find division. Now we are moving forward, and we will see that if the binomial, whatever binomial you have here, if it is a factor, then that means the remainder should be 0. So divide this and write that division in remainder theorem form. Also verify that if there is any restrictions. So you have to work on that part also, that if there are any restriction. So for restriction, I think it's pretty sure you just write it 4x cubed plus 9x minus 12 over, when you write this 2x plus 1. Obviously, this will be your restriction. You say 2x plus 1 should not be equal to 0. That means x should not be equal to negative half. So that's the restriction. Okay, and we can do the divisions here. So I will look into some example. This is a word problem. It says the volume V in cubic centimeter of a rectangular box is given by this. Determine the expression for possible dimension of the box if the height is given by this. So basically what it means, we know that volume of any rectangular box is length times width times height. So if I do width over height, that means I should get length times width. So what I will do, first I'll try to divide it. Okay, so divide by this factor, negative 2. So I want to use here synthetic division. So I will use first coefficient is 1, second is 7, third is 14. Make sure students, if there is any term missing, you have to put 0 coefficient for that. And then start dividing it by negative 2. Why? Because we have to change this sign. We have to solve the value of x. So bring 1 down. and 1 times negative 2 is negative 2, so then 5 times negative 2 is negative 10, and then 4, and 4 times negative 2 is negative 8, and you can see your remainder is 0. And you know it's possible because your whole volume is basically length time width time height. So the expression that I'm getting here, which is basically length time width, is your x squared plus 5x plus 4. And then we have to find the factor of this, and you know this is a quadratic, so you can look for two numbers which multiply to 4 and adds to 5. So the numbers are 4 and 1, and your expression will be x plus 4 and x plus 1. So the other dimensions are this x plus 4 and x plus 1, and you know the height is already given. And then you can also get a question that what will be the volume if x value is say 10. So simple, just plug the value of x. So we can write now Vx expression will become x plus 2 and then x plus 4 and then x plus 1. So if the value of x is 10, then the dimensions are 12, then 14 and then 11, and you just multiply them, you will get a volume. Okay, and then we can also move forward. They are saying determine the value of k such that this is divided by this and the remainder is 8. So basically we are saying that when we divide it by 2, where x is the factor, x equal to 2, then the remainder should be 8. So I want to use the same synthetic division. You can use still say, whatever you want to use. So I will say 2 negative k, then 8 and negative 12. Don't put them together so that they look like a single number. Okay, and then here we are going to do 2. So bring first 2 down. So 2 times 2 is 4, and here when you do this you will get 4 negative k, make sure, and then this will be multiplied by 2. So it is similar to like you are doing 2 times 4 minus k. So I'm going to do all together. It will become now 8 minus 2k, and when I bring them together here it will become 16 minus 2k, and then again I am going to multiply it by 2, so it should become now 32 minus 4k, and when I add these whole terms together it should be 20 minus 4k. Now they're saying, you know, this is our remainder, and they're saying the remainder is equal to 8. So set it equal to 8, and you will get minus 4k equal to 8 minus 20. So minus 4k equal to minus 12, and then divide both sides by 4, negative, and you will get k value as 3. So when the k value is 3, then you will have this. And when the k value is 3 and you try to divide it by x and negative 2, then you're going to get remainder as 8. So you can try this kind of question. This is your remainder theorem. Okay, now I will move to the next one now, and that's your factor theorem. So let us see about this. So as we already know that if we say that one number is a factor of another number, that means when you divide these two numbers, your remainder should be 0. Okay, so if it is a factor, then that means dividend should be equal to divisor multiplied by quotient. So this is another form of writing the polynomial, and it says that this is what you have to remember, students. It says that if x minus b is a factor of polynomial px, then pb need to be equal to 0. And if ax minus b is a factor of polynomial, then pb over a need to be equal to 0. So what essentially it means, so for example, say x minus 2 is a factor of this. That means the value of x equal to 2 should satisfy this expression. And it's a factor, that means here y value need to be 0. Okay, so what you will do, you just plug the value of p, find value p2. So I will do here 2 times 2 power 3 plus 3 into 2 power 2 minus 3 into 2 and negative 2. So you will get here 16 plus 12 minus 6 minus 2. Okay, so you will get 28 negative 8, and then you get 20. Now since you are getting a value here, that means this is not a factor. Okay, and same way you can try this now. So let me try let me try this one, negative 2. So if it is negative 2, it will come 2 times negative 2 cubed plus 3 times negative 2 and negative 3 times negative 2 and then negative 2. Just remember, I replace x with its value, which is negative 2. So I will get here negative 16, negative 6, and then I get here plus 6 and then negative 2, and again you are getting here, I'm getting negative 18, and still it's not a factor. Let me try last time with x -1. So I will do 2 times -1 cubed plus 3 times -1 square, -3 times 1. I think we missed square terms, students, here, square. Okay, so this should have been -12 here. Okay, so just correct this math, but I know that is still not a factor. So and then -2. So this should be -2, then plus 3, then -3 and -2. And luckily you see this is a factor because we are getting a value 0 here. So that way you can figure out the factor. And for this expression, what you are going to do now, you are going to plug x as equal to -1/2, and that is corresponding to this. That if you have ax plus b or x minus b, then again filter out the value of x and plug it back. That's the same thing. Okay, so go through this question, and it says, remember this is integral zero theorem. It says that if x minus b is a factor of a polynomial with the leading coefficient 1 and all its coefficients as integer, then b is a factor of its constant term. Okay, so factor this one using integral zero theorem. So what we have to see, we are looking for any factor, okay, of this polynomial where the leading coefficient is 1. You can see leading coefficient is 1 here, and all its coefficients are integer. You can see here these are integers, even including this. That means integer b is a factor of constant term. So what are the factors of this 6? So factors of 6 are 1, then we have 2, then we have 3, then we have 6. So we have to figure out plus and minus of this, plus and minus this, plus and minus this, and plus and minus 6. Okay, so the main thing is whenever you have this kind of function, the main thing is you have to find one factor. After that, you know it's a quadratic and you can solve it further. So let me try with 1. So I will try p1. P1 will be equal to 1 plus 2 minus 5 minus 6, and I think it does not make, so it's not a factor. And then you do -1, so it's become -1 plus 2 plus 5 -6, and your job is done. You can see you're getting value 0. That means x equal to -1 is a factor. That means x -1 is a factor of this whole polynomial. And what you will do now, you will do that synthetic division or long division, whatever you want to get, do, and then find the quadratic expression out of that. So I will quickly do this. X cubed plus 2x square minus 5x minus 6, and try to, I'm doing long division here. Okay, so x minus 1. So I'm going to write quotient here. So first x square, so it's x square minus x cubed, sorry, minus x square. So you will get here 3x square minus 5x. Then you do plus 3x square, 3x, sorry. So it's 3x square minus 3x. So again, when you do subtract it, you will get here -2x, -2x, -6. I think x, oh, it was x plus 1. My bad, students. This was x plus 1 here, because x equal to -1 is the factor, not, it should be x plus 1. That's why I was not getting this 0 here. So quickly let's try one more time. So this is x plus 1, and we have this here, x cubed minus plus 2x square minus 5x minus 6. So to start with x square, so x square plus x cubed plus x square, and then you subtract it, you get here x square minus 5x, then you do plus x, you get x square negative x, and then you get here -6x, -6. So you do with -6 here, you get -6x, -6, and it's 0. That means it's a remainder. So this way you can figure out the remainder, and once you got this expression, now it's easy for you to factor it further. And also from here I can see the value could be x plus 3 and x minus 2. So by using this integral zero theorem, you can figure out the factor, and keep on trying these factors if you are not getting the first solution. Okay, and then factor this fully. So again, now again this coefficient here is 1, and then we have all integral values. So the factor of 18 you have to try with plus and minus sign. So the factors are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, and plus and minus 18. So you don't have to go that far. I'm sure when you try up to 1 or 2, you should be able to get the answer, and then you can try the next factor. So we'll try this. And this is again, so this is about the rational theorem, where this is when your fact is basically a fraction. So that is what we have to talk about here. So this is the one that we are talking here, this one, this thing. Okay, so you can try that also, same process. Okay, in this case now, the leading coefficient is not its leading coefficient is not 1. So in that case, what factor you should try from the integer, this value, that means plus and minus 1, plus and minus 3, and then you should try from here, that means for this number leading coefficient only. So it should be plus and minus 1, plus and minus 2, and then we have to try one more, but it says that these divided by this. So divide by this. So like say I should also try plus and minus 3 over 2. Okay, that's only additional factor that I have. Otherwise plus and minus 1, and then we have from plus and minus 1 we are getting here plus and minus 1 over 2. So those are additional factor that we should try when the leading coefficient is not 1 and all other integers, all other factors are integers, all other coefficients. Okay, again we have the similar kind of question here. They say determine the possible dimensions. So whenever I have to find the dimension of this, I should take the factor of this, which is plus and minus 1, plus and minus 2, and then we have this plus and minus 1, plus and minus 3, and then I should also try 1 over 3 and 2 over 3 with plus and minus sign. And once we get that one factor, you can figure out the other factors. Okay, so try these kind of questions. And here, this is the cube root. So this is basically a cube plus b cube, and this is, if I have to do it, it's a 5x raised to power 3 minus 4 cubed. So this is a cube minus b cube. So we have to apply this formula. A cube minus b cube is a plus b into a square negative ab plus b square. Cross check it one more time just to make sure it's everything right. And a cube minus b cube is a minus b into a square plus ab plus b square. So again check this. Okay, so that's all we have for this video. We'll keep continuing posting more on it. So that's all for today. Thank you.